NanoVNA theory and operation. I did this, and I also used ChatGPT. If I was having trouble with inspiration on how to write this thing, so I asked ChatGPT, what is a NanoVNA and how is it used in amateur radio? And it gave me the beginnings of the presentation. As you go through this, you will see definitely where the AI was involved and where I was. Yeah, you'll see. The AI is not near, it is more repetitive and not as robust. So, next slide. So what exactly is a VNA? Vector network analyzer is a device used to measure the complex impedance and other electrical characteristics of a radio frequency network. Provides valuable insights into the behavior of antennas, transmission lines, filters, amplifiers, and other RF components. So it's valuable in the shaft. VNAs operate by injecting a known test signal into the network and measuring resulting signals to determine the network's characteristics. So we'll do a quick overview. The NanoVNA is a specific type of VNA. It is very small and has gained popularity because it's small, low cost. I mean, I think I saw somebody at Ham mention selling it for like 35 bucks, real cheapo ones, and very portable. You can actually buy kits. I think George has a kit version. Consists of a handheld device with an integrated touchscreen, a microcontroller, and RF circuitry. It operates on the frequency range typically used by amateur radio enthusiasts. So depending on the model, it'll go down to 10 kilohertz. It'll go up to 5 gigahertz. And all frequencies in between. So the features are frequency range. Mine is 10 kilohertz, I found out, and it goes up to 3. Depending on your model, you can get different versions that will have a different frequency range. Your measurement parameters, it can measure various parameters, including impedance, reflection coefficients, transmission coefficients, and the phase angle. So again, these are some items as a ham radio operator you should be familiar with, at least these terms. So when you actually start digging into this, you'll understand what's going on. And the touchscreen interface. Mine is very, very persnickety. So when you see during the demos, it is very persnickety. And it's also an older model. I think I bought this thing about 3 years ago when this one came out. And it's battery powered, so most of them are rechargeable, so you can use them in the field. And again, it's small and it's handheld. I'll show you mine in a minute. So the NanoVNA F is for fairy. That's the guy who designed it. That's what because it's one of the smallest ones out there. So VNAs have been around for a long time. They are very big, massive pieces of test equipment up until recent. Now all of a sudden we have this whole plethora of these small nano ones. They are not as precise. So some people who are RF engineers will put their noses up at it because they're just not as precise as they need them. But for our work, they are pretty damn good. So you can see 50 kilohertz to 1.5 gigahertz, 301 data points. So when you're taking a look, this comes into play as you're taking a look at your frequency. It will take 301 data points. It takes approximately 2 seconds to sweep. So it basically will go from the start of your frequency, your beginning stimulus, to your end stimulus, and it will sample 301 times. You can change that. Sometimes you want less, sometimes you want more. More depends on your unit though. This one only goes up to 301. There's some units that do go up to 501, some of the newer ones out there. Your reflection coefficient, transmission coefficient, so you see the 2 ports on there. And then the dynamic frequency range. So the reflection coefficient has a certain range and the transmission coefficient has another. Mine has a 4.3-inch IPS LCD screen. Some have bigger, some have smaller. So this is what the exterior looks like. You see that it's basically a touchscreen, got some ports on the side. In the back, it has a nice little diagram talking about what it's doing. So it's actually taking in input and output. So that's where you get your reflection and then your input. Transmission reception. We're mostly using the transmission one. And then my particular model, they have a Type C used to charge the unit, on-off switch. There's a connector. I did not really explore in hooking this up to a PC. Some people hook these up to PCs. Mine, I always use it out in the field. I almost never have it next to the PC, but you can actually, there's software on there that you can use to control the device through there instead of the touchscreen. And mine has a rocker switch. A lot of people complain about that. They got rid of it. Now they have like 3 switches instead. You open it up and that's what you got. It just basically, it's the screen on top of your board. You flip it upside down and there's the big fat battery on there, again, covering up the board. And then when you pop that open, that's actually what you got. There's microcontroller here in the center. And then you have your shields over here for your different RF controllers for your input and output. And then your rocker switch, again, this is flipped upside down. But yeah, I mean, there is really not that much to it. The brains of it are that microcontroller. And on boot up, this is what you get. You get a nice screen that tells you some of it's customizable. I was able to customize and put my call sign and my email address in there, what version it is, and when it was built. So there's a little bit of sorted history here because there's two different companies that are making the NanoVNAs. There's Sysjoint and DiBenedetto. Next slide, or not next slide, the next one. So this EDY555, he developed an open source NanoVNA kit that was fairly popular, but it was a kit. You needed to buy a lot of other components for it. Then BH5HNU, he developed the NanoVNA F. There's also an H. I think the EDY555 developed the H for handheld. Barry is just an improvement on the H version. And he also started offering the kit from the company Sysjoint. He then developed a version 2.2 for his company, DiBenedetto. And I guess there's a big court case going on, or there was, about property rights, who owned what, because I guess he basically took and made improvements on DiBenedetto or on Sysjoint's time and then started selling it under his own company. Next. And then he had developed the 2.3 and 3.1 for DiBenedetto. Sysjoint then develops the NanoVNA FV2. This is where I got confused. I'm trying to help you with some confusion here. Just because the VNAF version 2.2 and 2.3, they are siblings to version 2. They diverge off from version 2. Because that was the problem I had, was I'm like, oh, okay, well, if you pop mine open, you'll see mine on the inside actually is a NanoVNA F version 2.8. So I'm like, oh, okay, well, I should run, no. It's not a version 2. Mine does not run that software reliably. So you don't necessarily want to have that firmware. So there's, go on. Then he developed a VNA 101, and that's basically diverged off from that one. So you have to be very aware, just because you're in version 2 dot something doesn't mean it's the version 2 from Sysjoint. The firmware is very confusing. Basically, that FlyOOB there, these are GitHub repositories. So you can actually go out and get some of that software. Basically, FlyOOB created the software that was running on the hardware that EDY555 developed. It was open source. The problem was that the last time it was updated was August 24th of 2020. Then DiBenedetto did a version of it, but then they closed off the source. So they did their own version. And then that one kind of died off too, right around the same time period. So it's kind of funny because it says the release was 0.1.5. It's actually the 2.1 and the 1.5 are not related. And then DiBenedetto put together for the 101, the version I'm using, 105. There's 3 versions of it. So your mileage may vary. You can either have the 2.2 or the 2.3/3.1 or the 101. Mine, the 2.3, 3.1 works fine with my version 2.84. So again, your mileage may vary. But one thing you have to watch out for is the older ones used a different flashing technique. The newer ones have a much better flashing technique. You basically hook it up to a PC, you hit the button, hit the power, and it then goes into a disk mode. You'll then see a disk mounted on your computer. Works fine with Mac, Linux, Windows. And then you just drop the bin file in there, and it will then unpack itself and install it for you. The older version, you had to actually like hit a switch to go into reset mode. It was messier. I ended up flashing the ROM. I did that, but I flashed the ROM with the bootloader that gives you the disk, so I can't go back with it. So just be aware of that. I haven't regretted it. I like this new version better. Like I said, it works fine with my hardware. So quick start guide. Most of these are you can see a quick start guide that comes with it. And basically all it does is this is where I got confused, like what's all these menu settings? That's where you need to start getting into tutorials to see what's really going on. And that's where I'm going to help you with this stuff.
QR code?
Yeah, that's a QR code to get this. I also have the URL at the bottom. And you have to watch because you need to make sure the quick start guide matches your firmware version because they do change. So operation, this is what we want to know. This is where things go. This is what you need to do generally. You need to configure your frequency range. You need to calibrate the NanoVNA. Every time you set the range, you should calibrate the VNA. If you save the configuration, you're okay. But I find myself tweaking it far too frequently. It's a good idea to calibrate. Oddly enough, the most annoying part of the calibration is unscrewing the stuff from the SMA connectors. Connect your DUT, device under test. I call it device under test because the NanoVNA measures more than just SWR on your antenna. And you can measure all different types of things. Your antenna, the feed line, line loss, line length, your amplifier, your inductor, your capacitor, whatever. Those are all devices under test. You perform your measurements and then analyze your results. So it's basically everything is, you're going to see all of these are done in this fashion. So to configure your frequency ranges, you go to the stimulus menu. You can do start, stop, center span, or the version I have is nice because it has amateur frequency. You go to the amateur frequency, you'll see the only problem is it's region 1. So the 40 meter does not cover our entire 40 meters. So I ended up saying, okay, that's that. But those are already pre-calibrated. But you start, stop, you basically enter whatever start frequency you want, whatever stop frequency. I have one that's defined for basically the entire HF going from 1.8 all the way up to 30 megahertz. So I can see, like if I have a broadband antenna, where am I seeing those dips? But remember, it only takes 301 points, sweet points. So that frequency range of approximately 29 megahertz is going to be divided into 301 points. So your resolution is not so good. So I do recommend that you do go and narrow down the frequency that you want to get. The other one that I find useful is the center and the span. So you enter the center frequency you want to measure and then how wide you want to measure it. I find that one useful because I will go and say, I go and say, 14.175, which is the center, smack dab center of our 20 meter band. But I make sure it goes wider than that because I want to see it's good. My SWR is good, but I can make it better. Where is it better? Is it better? Do I need to add some length to it? Do I need to add some passings to it? What do I want to do? So by making sure I see a little bit of the edges there, I begin to see where the curve is going. CW frequency, I'm not sure what that is. So then calibrate. You basically, most of the time you're going to do OSL, open, short, and load. You can do isolation and through. Open is basically, you're going to have an open connection on the transmission port. You're short, you're going to short it out with a 50. Our case, it's sent in with a 50 ohm resistor. I'm sorry, short is just going to short. Load is going to be a 50 ohm resistor because we are concerned with 50 ohms, also our 50 ohms. You can buy other terminators though for 75 ohms or whatever else you're looking for. Isolation, I actually bought another pack of 50 ohm resistors so I can isolate my two. And then the through, you basically just connect a line for the two different ports. And the idea behind the isolation is, actually the entire idea behind the calibration is twofold. It's going to try to take a look at any internal noise coming from the system and isolate that out. And it's also going to set what's called your reference plane. So I sadly forgot a piece of test equipment that I was going to show you. You always have to recalibrate it because the line length is, I bought like a 2-foot piece of cord, of cable or whatever. You want to calibrate it with because the device under test is going to be at the end of the cable. I don't want to include the cable. So you want to calibrate with the cable on there. And I actually have a 50 ohm resistor, which is your traditional, Carter resistor for that very purpose. It has alligator clips on the end of it. So always keep that in mind with your reference plane. You want right now, the reference plane are those SMA points. So anything you add on there is part of the device under test. If you're going to want to, like for example, if I go to test my SWR, but I don't want to have the transmission line in there, I can disconnect the transmission line, measure or calibrate it with the transmission line, but no load, and then put the load on there, and then I isolate that. Get done, it'll let you save. You get 6 saving spots. It'll show you what they are, what frequency ranges. Calibration terminators, they're gold little things, they're kind of hard to tell. The open is the hollow, short has a little needle in it, and then there's a stainless steel load. Those should come with the device. So again, calibration pro tips. You're changing the reference plane. Always think about where you're measuring to, where you want the device on your test to start at. When I'm calibrating, I hide all traces except for trace 0. I'll show you that in a little bit, i.e. S11. It's not S11, it's not S21, it's S11. So, basically what that is saying is that you're sending and receiving on 1. 2-1 means you're sending on 2, but receiving on 1. So I hide all the traces except for that first one. I set my trace to the Smith chart because when you go and put the loads on there, when you put the terminators on there, you will see it move along the Smith chart. And you wait for it to settle in, probably about 3 seconds before you calibrate. You can calibrate too quickly and get a bad calibration. So again, the open will be on the right. This is from your general, I think. Did they talk about Smith charts in general, or is it extra? Yeah, so you'll see your open will be on the right. Next. Your short will be on the left. And then your load will be in the exact center. So that means you know that you're good to go. So to measure SWR, set your frequency range, calibrate it if you need to. I set and display trace 0 and trace 2. It removes a lot of the noise. Some people like all 4 of them. I just go with 0 and 2, and I'll next one. I will set trace 0 as the SWR, and I set trace 2 as the Smith chart, so I can kind of see where I'm leaning. Am I too long, too short? You know, things of that nature. And then scale as needed. So if your SWR is high, you want to set your scales with a multiplier or a divider. And you can use the marker. The marker is kind of cool. You use the marker to show you maximum, minimum, things of that nature. So, all right, back up. And now put the camera on. Well, I'm going to show you. Start off with this guy. So once you actually get the hang of this, it's really not that hard to do. It's kind of confusing to begin with. There's so much on there, so many different options and terminology that once you get the hang of it, it's a really easy tool to use. I recommend, as part of it, you get some type of stylus, because doesn't matter how thin your fingers are too fat for this thing.
Some come with a little triangle.
Yeah, mine had a triangle.
Yeah, I saw somebody with a guitar pick.
It's what I think.
Yeah, mine is her old Nintendo DS
Yeah, that'd be great.
pointer. So I'm going to go to config, and I'm going to do touch calibration. Okay, did you see that? Mine never calibrates right. So you can push in the button and get the menu and then scroll down. And I always do this, and it never seems to work.
Well, you're trying to calibrate the screen.
This is calibrating the screen, and for some reason, my top right corner, I think it's damaged. It just doesn't work quite right. But anyway, so we're going to calibrate. And we're going to go and do. So I can go do recall. So these are my saved ones. So I can really quickly recall, you know, my number 4 there. You probably can't see it too well. My number 4 is the 20 meter band. But you can also go and do calibrate. I didn't put this on there. You want to reset your calibration. Calibrate. And now this is where I left the SWR on there, but you can see the Smith chart there. Okay, so I'm going to do the open first.
Doesn't autofocus.
Oh, that's fine. I'm doing port 1 right now.
Hang on.
So now you notice that the little green marker kind of shifted to the right a little bit. I waited a little bit so it's solidified, and then I hit that. It says perform open calibration, please wait. And it's done. It does 2 passes. So depending on how fast yours is, mine takes about 4 seconds per calibration. So I'm going to do the short, Same thing, tiny little one. You see that little pin in the center there? That's going to shorter out, and you see, watch that shift on the Smith chart. Same thing. Like I said, most of the time is screwing and unscrewing. Do the load. And yeah, I forgot my other kit. I have a whole bunch of other. Isolation, you should put 50 ohms on both. Like I said, I forgot my other one, so I'm just going to. It's.
First stuff, you already don't really need it.
No, you don't really need it. You don't need the through here either, but I'm going to show people again, just to give you an idea. So it comes with some leads.
Interesting, for open, you do need the connector, because the connector makes a slight difference.
Yes, it does. So I'm not going to save this one because I've already used up all of mine. I'm just going to go back. And what you then do is if you don't hit done, because you're not going to save, you just hit apply. And now it's applied the calibration. You saw everything kind of shifted around there. Well, you don't, but. Does anybody have any questions? Yeah.
Yeah. I have one, and I used it for quite a while, but I had next to zero trying to use it as a TDR.
Okay.
It just would not work for me, and to the point I was in total frustration with it. Have you ever tried it that way?
I use,
Time to main reflectometer, measuring coaxial length for a break or something.
I'll show you that. I do. I have a demo on that. Yeah.
Right, yeah, I just couldn't get it to work.
Yeah, there are a couple things. So I apologize there. I forgot couple of the test pieces. So I was going to show measuring capacitance. I had a rough time with capacitance. And part of the reason is, remember, capacitance and inductance are very much dependent on frequency. So there was a trick that some guy had that made really, really good sense. Look for your phase angle to be complete reactance. And then you're going to see that, and it worked out pretty well. So I talk about how to do that. I'll get to that in a minute. Yeah, we're good to go? Okay. So we calibrated the unit. Oh, you know what? We didn't set the stimulus, did we? Let's set the stimulus first. Okay. So we're going to do. And just 14 to 15. You know what? For sake of time, I'm not going to calibrate it, so I'm going to do a recall. But you use, again, it's kind of hard to see, but you see there's the start and stop, center and span, and then CW frequency, and then the amateur frequencies. You can, and then, like I said, they have the list. But if you take a look over here, their 40 meter goes from 7 to 7.2. Yeah, they do have the 30 meter in there. But it is useful. I mean, they do have the 2 meter and the 77 meter and whatnot in there. So I chose 20 meter. And basically, I'm not connected. That's why we're not getting any reading. Yeah, I was talking about this earlier. This was connector hell. I mean, this thing has an SMA on it, but I have BNC because a lot of the stuff that I'm using the BNC for is photo equipment, and you need a BNC. And most of the stuff's with BNC. So there, you see the frequency response on this guy here. Not too shabby, because I think I was using it for 40 meters the other night. So what you can do is you can go to the marker, and interesting. I was going to show. I forgot the radials, because I was going to spread out the radials and show you how the SWR changes as you spread out the radials. But so you can see here it starts at 325 down to 1. So you can go and change the display and the scale. Change it to 1. And it goes from 1 to 10. Or you can change it to 0.5. So it goes 5.5 to 1. So you're able to change the scale that you're looking at to see the SWR. Then you can go to the marker and you can search for the maximum SWR in that frequency range. And you see over here the M, 14 megahertz. So that's where the maximum is. It's kind of hard to see
If you
right there.
ever try using log mag, you can see that sometimes a lot better.
I do that, yeah, I've done the log mag before but it's usually for measuring inductance capacitance.
You can see where the SWR is also on log mag.
Well, you can also do the minimum there, and it tells me that, again, I'm also in the near field here. The minimum is 14.22. You can also use the rocker switch. I don't know if you can see that little yellow guy moving around.
On the end.
Yeah, it also allows you to. So you can see here where most of because of the Smith chart there, you can see most of it is resistance. So I should be getting I'm getting most of the power is actually going to the antenna as compared to. Now, we can do, that's the nice thing about this guy. That's still not bad.
What are you doing? Change the band?
Changing the.
I'm changing the inductor.
Yeah.
I'm changing the coil. So now you can see it doesn't really show you what the SWR is. You can see at the top over here, it does say 6.3. So if you go to the format, whoops, scale division. So you see it's pretty flat across the 6 SWR. So yeah, that's really how you do SWR. Another one. The adapter. This is one of those antennas that they were being bought up like crazy at Hamvention this year. I even bought one for technically Julia bought it, it's for her radio. This is a 2 meter and 440, it's dual band. So I'm gonna go back. No, wrong config. Stimulus amateur frequencies. I'm gonna grab the 2 meter band. And there we go. Now here, your mileage may vary because technically this thing is supposed to be using the body and your stand as part of its ground plane. But still, that's not that bad of an SWR. Well, actually, it is actually kind of bad.
You look at the Smith chart, it's of everything.
So. So the SWR on that thing is about 2.5 across the board.
Yeah.
But as I said, if you come in here and start putting your hand around here, you begin to see it drop. So if I'm pulling away from the camera. So if you start holding it up like you would, yeah, it's 3 now. So yeah, this one I found weird. My other one, if you hold it up, it actually gets better. This one, when you lay it down, it gets better. So, again, it's your mileage may vary, but I don't think it's the unit. I think it's the antenna. And I was reading about that. I started to do some research into HTs, antennas. Let's do something really quick here. This guy. See what he looks like on 70 centimeter because he's supposed to be dual band. And that's what it looks like on 70 centimeters. So a little high, but still, HT will work it. All right. Go back to the presentation, please. So that's SWR. That, me personally, that's the guy I'm constantly using. But there are other things that you can measure as well. All right, so I'm going to talk about measuring inductance and capacitance. Again, I forgot the test lead that I need to test these type of components. But it's the same thing. You're going to set your stimulus, your frequency range, what frequency you want to go to. And what I recommend you do is you set it as low as possible. So that's where I found mine's 10 kilohertz. Set it as low as possible because a lot of these components are way, way down there. Calibrate it, and I usually go up to like 50 megahertz. Set display trace 0 and trace 2. Format trace 0 as reactance. Trace 2 as Smith. And again, this is all preferences. This is how I found to be, for me, the best way to do this. I set my marker to the Smith value. I use the R plus LC. You can go though in the marker Smith value and pick which one you prefer if you want to see it as imaginary or whatnot. The guy recommended that you look for a plus or minus 50 ohm reactance on trace 0 on the Smith chart. That will then tell you, and obviously it's positive if it's inductance, negative if it's a capacitor. And that will give you and every time I've done this, where it's been in range, it's come up. So you can see I measured a 10.3, the 1003. And you see I found the reactance here is negative 50. You can see where we are on the Smith chart here. And you see it's 10.7. That's pretty close to a 103. I mean, it's not that, and considering it's I think it was a bad capacitor. It was like a 10% tolerance. It wasn't a very good tolerance. So I think that was well within. So
Ceramic and stuff.
yeah. Yeah, I had an electrolytic that I tried, and the electrolytic I could not get it to work right. I think it's because it was too big and it needed to have a much lower frequency. Because one of the things you have to watch out for is, you see this guy right here, you have to watch out. At some point, the capacitor and the inductor can become self-resonant. And then you start going off the charts wacky. So that's some of the things you have to watch out for there. Again, I had a bunch of capacitors I brought with me. I was going to show you, but I forgot to test the lead, so I apologize. I'll bring in the field day. We can do more demos there. This one I found fascinating was measuring transmission line length. This one's a little different. You're going to turn off all traces except for trace 0. You're going to format it to trace 0 to be linear. Select your transform as a low pass impulse. Select the and then turn your transform on. And then your stimulus. Start at 50 kilohertz. Stop depending on your length. So I saw a bunch of different people come up with a bunch of different formulas. That's your formula for your stop frequency, but I don't know about you. I don't know necessarily what my velocity factor is in all my lengths of coax. So, and it's one of those, again, your mileage may vary. I found that 1845 empirically. I just started testing around and I found that number actually seemed pretty good. So if you're going to measure 100 length of coax, then you take it, basically you're going to put in what is that? 18 megahertz, something like that. And it works pretty good. Some guy had a much different number. I think each unit is a little different depending on how it's doing its measurement. And then do your marker search for maximum and you'll see. So let's leave that up, actually go back. And I'm going to measure transmission line of this guy. Well, let's see, display. So here's where you set up your traces. We're going to get rid of the trace 2. You essentially double click it. We're going to then do linear. All right. All right, do a quick calibration here. And this is probably the slowest part of doing the measure, was having to calibrate as I was playing around with those stops. And I don't know if you can see across the top of the screen, when it's doing the sweep, there's a line growing. You can watch that as it's doing the sweep, so you know where it is. Yeah, see that little white bar kind of going across the top? It's amazing how much they, oh, shoot, you know what I didn't do? I was supposed to tell me what I didn't do.
The range.
No, I said that. I
Oh, you reset.
did a reset. So, and here's, you'll see there's, as I go and calibrate, to do it correctly this time, you see how in the left column, it's empty there? See how there's an O there now. So that means it's calibrated for open. So those are some of the nice features that different firmwares will give you. Some of them have, like the 101 version has it across the bottom for some reason. We're only going to do, we don't need to do all of them because we're not using the reports. Will really come into play. Okay. That was. Do me a favor, bring up the presentation again. Trace linear, transform.
Does your line need to be straight?
No, not yet. There it is. Okay, so we, no, just hold on one second. So select transform, low pass impulse, and then transform on. So now you can go and put it on there. So there is the transform menu off the display. Low pass. Transform on. Yeah, for some reason it's not working. Go back to the instructions again if you don't mind. Set trace zero, set trace zero to linear. Huh,
You have your stimulus, right?
yeah. Yeah, I'm doing 10 kilohertz. That was his 50, doesn't matter. Stop frequency 1845 divided by the max length. And I said 100 meters. Because it, as Greg said, there should be a straight line. And it should be at the bottom.
I was talking about your wire itself.
Oh. Yeah, I haven't seen it do that before. It's normally been okay with whatever wire I put on there. I tested this one earlier, coiled up, and it was fine. Yeah, it's supposed to be a straight line. And you're supposed to see the bump.
How long is your cable?
This one I believe was 25.
25 meter or 25
Feet.
feet?
I don't.
Your length's in meter in your formula.
Right. Yeah, so 25 feet though, that's not 100 meters.
He's got his max set for 100 meters.
Yeah.
Right, so
okay.
that's 300 feet.
330 feet. Yeah.
Possibly, yeah, exactly, yeah. Let me see, give me a second. Let me. Trace, turn them all off. Okay. Format. To linear, yes. Transform.
Yeah, but I think you're going the wrong way, Cesi. It's the shorter your cable, the higher your maximum frequency needs to be. So because your cable is less than 100 meters,
Okay,
I think you need a higher frequency for your max. Set it for like 10 meters or something. Set your max or your stop frequency to like 100 or set it to like 200 megahertz.
Yeah, see, it's supposed to be a flat, straight line. And it's still coming out that. It's not supposed to be doing that.
Oh, well.
Yeah, let's go to the next, and then I could keep working on that. People want to hang out and see what I did wrong.
Cesi, if you're measuring the transmission line length, that's with nothing connected at the other end.
Yeah.
Mhm. Yeah. So transmission line loss, I don't know if I can do this one because I might have forgotten a piece. So again, it's going to be your select your frequency range, because again, your loss is dependent on frequency. The calibration. Connect one port to port 1 and one end to port 2. Display trace height, all traces have trace 0. And this is where I found the log mag actually works out pretty well. And let's see if yeah, I don't have the other VNC connector to show. I meant to show that one too. Again, if you follow these steps though and play around with it a little bit, you'll eventually figure it out.
You're gonna post this pretty soon, right?
Yeah. The one thing I do need to do is go through the benefits and I'll show what I need to finish up there.
Sure.
So,
Those screens you're showing are right out of the manual?
no,
No.
those screens were,
Well, he thinks there's a manual.
Paper about.
yeah, there's no manual. That's part of the problem.
Oh,
No, so there was a manual for the kit. It was in Chinese.
Yeah.
Someone interpreted it, but I don't think they were really a ham radio operator because there was stuff in there that, or they might have done Google Translate. Yeah, I have a piece of computer equipment from Japan trying to use Google Translate, and it's like, I know that's not what that's saying.
be glad
Be glad it's not big.
You have no instructions on how to use it.
There's lots
A lot
of.
of meters.
A lot of it, that's why I was gonna say, at the back page is a reference. I need to update that because I did a lot of these videos, and the problem you end up having is everybody has their own flavor of way of doing it. How you feel with it, how you want to display it. I had one guy, I don't know how he did it. He had all 4 traces showing, but they were all pointing to the transmission line. I have not been able to figure out how to do that. Mine, trace 0 is S11, trace 1 is S21, trace 2 is S11, and trace 3 is S21. I cannot figure out how this guy did it. So I'd like to be able to display, because he was showing phase angle and the log mag and the SWR.
And some of the promo, you could put all the traces on.
Right.
Pick it, if that's one or.
And the problem is that if you go to that one site, that volume, you can download that and tweak it to your heart's content and build it. And then flash it and you got it. The problem is that this guy, this B5HNU, he basically made all these wonderful changes, but he never put them back in. It's all proprietary now. So, but the benefits, budget-friendly solution compared to traditional VNAs, those things are massively huge. We have one at the office that is massive. Portable and compact, battery operated. And I basically use this thing all day before it starts getting yellow on the battery. User-friendly interface, it is pretty user-friendly when you get right down to it. But let me just put it this way, if you have a traditional VNA, this is a lot friendlier. Those things, you're basically looking at a huge panel of all these switches, lights, and knobs, trying to figure out which combination you're hitting. You're kind of doing the same thing here, but I feel that with the menus, you can do what I did and kind of do a cookbook. It's easy to do a cookbook. And then versatile, as you can see, antenna design, transmission line loss, the length does work. I'm gonna get that to work in a minute.
As far as coils and capacitors, it does other things besides SWR.
Yes, so you could test amplifiers, as a device under test. So you set what your reference plane is, then you can hook up your RC filter.
And a coil and capacitor type thing, parallel circuit, do those.
Right, because all it's doing, so you think, to do this thing black box, whatever is going into that port and going out of that port is going into a black box. You may know what's inside that black box. It doesn't know. All it's saying is, I'm seeing at my end of my reference plane, at the end of that socket, I'm seeing these characteristics. So if you put an inductor on there, you will just see inductance. You put the capacitor on there, you'll just see capacitance. But resistance, you'll see resistance. If you start combining together in all these cool patterns, tank circuits, yes, you will begin to see, it'll act, you will see those characteristics. So the idea behind this piece of test equipment is you can, when you design something, verify that what you built matches your design, that you're seeing the performance as expected. You're seeing the return values coming back. You're seeing the phase angles coming back. That's the idea behind it. So it's really useful for transmission line debugging, antenna. I mean, like I said, you see how small that thing is. That slips in my backpack when I go out on POTA, and it takes no time at all to adjust my antenna and get a nice good SWR on that antenna. I mean, you saw that antenna. I had it down pretty much to almost all. I almost got all the reactance squared away. Got shuffled off the side, so it was almost all resistance. I mean, that's what a lot of us are going to use it for. But there's nothing stopping you from putting together a tank circuit and measuring your tank circuit to make sure that it's oscillating at 7.2. So
You mentioned they'll go down to 10 kilohertz.
certain models, mine does.
All right, loaded question. If you're gonna go buy one more, which one would you get?
I would probably do the 101. I like the firmware that the DiBenedetto version has. And I like the fact that it's being updated. I know Sister has a new one out, the V2, but I don't feel the V2 has as many features.
Big one.
I don't know if I necessarily go for a big one, because again, I take it's sitting in my backpack. But I would definitely buy one that comes in the box. I think George said he had a kit version. He's like, yeah, you gotta build a box. That's a nice thing. That thing is a nice metal box. So it tries to shield itself from the RF. And you saw on when I showed the picture on the inside, the ends where those connectors come in through their RF components is shielded as well. So this model itself is good in that regard. I feel it does a pretty good job of shielding things out. Yeah, so some limitations. Frequency range, limited compared to the high-end ones. Some of the high-end ones get into gigahertz, high gigahertz. You could probably buy some of these that are in the, like I said, this one will go up to 2, I think. There's a version out there that goes up to 5. But as I'm starting to find out with the satellites, they're going higher and higher frequencies now. So we may need higher and higher. But the problem too is that as you get into higher and higher frequencies, the more precise your measurement tools have to be. And that causes some problems. Right there. Reasonably accurate. I mean, it's good enough. I mean, I'm not going to get a 1.1 SWR across the spectrum. I just need to get it in close somewhere and let the radio do the rest. You get to that point where it's like, I'm trying to operate ham radio. Dynamic range typically lower. They struggle with high power signals or weak measurements. I really didn't run into that. In conclusions, NanoVNA, valuable tool, amateur radio enthusiasts, providing affordable solutions, bless you, for antenna analysis. Compact design, user-friendly interfaces, ability to measure and optimize antenna performance, various frequency bands. Limitations, excellent choice for the hobbyist. So, but any more questions?
How much one of those things cost?
So when I bought that one, I think that one was about $95. And I think I bought that, I think about it right before pandemic, so I think about 3 years ago. Like I said, I saw some guy hawking at an invention for $35. It might have been the H version, the older version, but I think I saw DX was like 150. I mean, they're really reasonably priced for what you get, what the versatility. The biggest problem is that you go and grab, you buy one, like, okay, this is cool. There's really no manual with it. What do I do? And this presentation really helped me dig into it and put it into good use. I've been using it a lot more now that I've been put this presentation together. Yeah, this is where I got to do some work on it. I need to put some of those videos that I watched. I just need to go and call the good ones. There's some that were a little questionable. I mean, I have one guy who was an RF engineer, and he was really going into how precisely you have to calibrate and everything like that. I'm like, okay, you're going to do way too much. All right, thank you.
All right, anything else? Thanks.